Good evening, everyone. Welcome to iQuanta. How are you guys doing? So we already have few students here. Pookie Pookie Painting, very interesting name. Hello. And then we have Rocky Ghosh. Hello, Rocky. So as per IPMAT preparation, crash course is going on. Okay, and practice classes are also going on uh, in afternoon, in the evening, in late night. So everything is going on that can help you guys uh, overcome this exam, to prepare this exam in the best way possible, right? And in between we are also taking sessions on YouTube, so you can be motivated, right? And now we are going to start. What are we going to start is क्वांटिटेटिव एप्टीट्यूड फार्मूले रिवीजन. बहुत सारे फार्मूले हैं ना, बहुत सारे फार्मूले हैं. पहला पढ़ो तो दूसरा भूल गए, दूसरा पढ़ो तो तीसरा भूल गए, राइट? So it happens like that in case of quantitative aptitude. So in that case we are going to have continuous session, same time 4:30 p.m. every day, okay? And we are going to revise every single formula in your syllabus. Okay, starting with numbers. Today we are going to start with number system, and let's see till what part of number system we can cover today. Now be aware that this session is totally for formula. We are not going to practice many questions unless required. Okay, if you are not getting any formula, then we are going to discuss few questions, otherwise we are not going to discuss it. Okay, so are you guys ready? Khushi, Mangla, good evening. Anurag, Amaira, Vishal, hello everyone. So, number system. How many of you like number system? Very interesting topic, right? But lots of concepts to learn. Note, see, there is already a formula book. Quantitative aptitude formula book we have, that we provide to our students. Okay, doesn't matter if you are enrolled or not, you can go to our website, you can join our Facebook group, you can join our WhatsApp group, and you can get that formula book for free. So if you, it's up to you. If you want to make the notebook, make it. If you don't want to make it, don't make it. Okay, but be ready here, be attentive here. First, number system, we are going to start with rational numbers. Okay, in case of rational numbers, what do we know? In case of rational numbers, the one important part is converting a non-terminating but repeating digit number into A by B form. So we are going to understand it from example. Okay, so 1, if it says 0.2222 and so on, this will be equal to 2 by 9. Okay, write down the digits which are repeating themselves, and as many 9 as many digits are repeating themselves. For another example, let's say 0.131313. So 2 digits are repeating themselves. Write 13, divide it by 2 times 9, 9, 9. Okay, then comes third, another example, 0.175 and so on. If you want to convert this into A by B form, this will be equal to 175 upon 999. 3 digits are repeating themselves, so 3 nines in the denominator. Okay. Now fourth one, when some of the digits are repeating themselves, when some of the digits are not repeating themselves, write 0.122222. So one digit is repeating itself like 2, one digit 1 is not repeating itself. So write down 1, 2, subtract the digit which is not repeating itself. How many digits are repeating itself? 1 digit. How many digits are not repeating itself? 1. So 1, 0 for that. This will be 11 upon 90. Then another example, 0.127 2, 7, 2, 7 and so on. This will be equal to 1, 2, 7 minus 1 divided by how many digits are repeating? 2 digits. So 2 times 9. How many digits are not repeating? 1 digit. So put 1 0. This will be equal to 126 divided by 990. You can simplify it yourself. Then comes another example. Let's say it's 0.123777. Okay, 777 and so on. This will be equal to 1237. Write down all the unique digits. Once subtract the number which is not repeating itself, like 1, 2, 3. Now how many nines? 1 9, because one digit is repeating itself. How many zeros? 3 zeros, because 3 digits are not repeating itself. This will be equal to 7 minus 3 is 4. 3 minus 2 is 1. 2 minus 1 is 1. And then 1 divided by 9,000. I hope this is clear. This way you can convert any number which is not terminating itself after decimal. Any number which is not terminating itself after decimal, but repeating, some digits are repeating itself. So take your time, understand it. Okay, I hope this should be clear to all of you, right? So as many digits are repeating itself, as many nines you put in the denominator. As many digits are not repeating themselves, you put as many zeros. That's it, as simple as that. Okay. I am sure all of you must have seen these type of questions. Now this is a very interesting approach, right? You should be able to solve those questions easily now. Okay, now let's go to the next part, and we are going to talk about natural numbers now. If we talk about natural numbers are basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is also known as positive integers. Now in case of natural numbers, summation of n, this summation of n is known as 1 plus 2 plus 3 till n, and this is equal to n into n plus 1 upon 2. Okay, then summation of n square, which is 1 square plus 2 square plus 3 square up to n square, which will be equal to n into n plus 1 to n plus 1 upon 6. Alright, then comes summation of n cube, which is 1 cube plus 2 cube plus 3 cube till n cube, which will be equal to n into n plus 1 upon 2 whole square, which can be written as summation of n whole square, right? This summation of n, this first one. Then we can use this to find further sum, like sum of first and even natural number. First and even natural number matlab 2, 4 plus 6 till 2n. First and even natural number. This will be just double of this, which is n into n plus 1. Then we can take the summation of first and odd numbers, which is equal to 1 plus 3 plus 5 till nth odd number, which is 2n minus 1. That will be equal to n square. Let me write this in language, that sum of first n odd integers is equal to n square. So these sums are really okay. These sums are really important and you need to know these values. These will be used frequently. Alright. So if you want to note it down. Okay. Now apart from this, what do we know in natural numbers? In case of natural numbers, what else do we know? So in case of natural numbers, we need to know about the prime numbers, right? We need to know about odd numbers, even numbers, their relation in between. Apart from that, we should know the number of digits and so on. So what we can say about the facts, some important facts. Okay. So first of all, about prime numbers, that every prime number has exactly two factors. Okay, that is 1 and itself. 1 and itself. What else do we know about the prime numbers? That every prime number greater than 3 can be written as 6k plus 1 or 6k minus 1, where k is a natural number. What is k? K is a any natural number, but the vice versa is not true. All right, vice versa is not true. Not every number of this form will be a prime number. Then the third one, 2 is the only prime number which is even. 2 is the only prime number which is even. Apart from that, what we can say? There are 10 prime numbers. 10 prime numbers are less than 30. Okay? 15 prime numbers are less than 50 and 25 prime numbers are there which are less than 100. Now, many of you forget these prime numbers, so I will write down all the prime numbers once and make sure that you don't forget these prime numbers, okay? 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, then comes 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. These are the 25 prime numbers less than 100. You should know these numbers by heart. Okay? If you don't know these numbers, you will have problem while solving the questions. Okay? If you instantly don't recognize a number is a prime number or not, you will have problems. Now tell me, am I missing any prime numbers here? Everyone, am I missing any prime numbers? Let me know once you are done with this. Then we will go to the next part, okay? Seventeen is missing. No, 17 is not missing. Tanjot. Hello, Barot. Done? Okay. Now, these sessions that we are going to have, okay. So, I will make sure that every single point is covered, okay. These are not practice sessions, okay. मैं फिर से बोल रहा हूँ, ये प्रैक्टिस सेशन नहीं है, ये सेशन है फॉर्मूला रिवीजन के लिए, कॉन्सेप्ट रिवीजन के लिए. छोटे छोटे पॉइंट जो भी हैं वो सारा कुछ हम कवर कर रहे होंगे, ठीक है. ऑल प्राइम नंबर्स आर देयर, ओके, थैंक यू. बच गए, है ना. नाउ सम इंपॉर्टेंट पॉइंट्स. व्हाट आर सम इंपॉर्टेंट पॉइंट्स दैट first one is a product of any n consecutive numbers, any n consecutive natural numbers is always divisible by n factorial, okay. If you take the product of three consecutive number, it will be always be divisible by three consecutive number, it will always be divisible by 3 factorial, which is 6. If you take product of 5 consecutive number, it will always be divisible by 5 factorial, which is 120. If you take the product of 10 consecutive numbers, does not matter from where do you start. Let's say 17 into 18 into 19 into 20 till 26. That will always be divisible by 10 factorial, okay. Then second, from 1 to 99, okay, every digit means 1, 2, 3 till 9 is used exactly 20 times, is used exactly 20 times, है ना. If you write down 1 to 99, if you write down 1 to 99, how many times 1 has been used? Have you seen a question like this? बताओ, ऐसा कभी देखा है कि 1 से 152 तक डिजिट 5 कितनी बार यूज हुआ है, 1 से 243 तक डिजिट 3 कितनी बार यूज हुआ है? Have you seen questions like this? If you have seen questions like that, those questions are based on this, okay, that from 1 to 99 every digit is used exactly 20 times, okay. And from 1 to 999 every digit is used how many times? Can anyone tell me? Every digit is used how many times? Example of the first, okay, see, if I ask you this, let's say k minus 1 into k minus 2 into k plus 1 into k plus 2. If k is an integer, this product is always divisible by which greatest value? This product, if k is an integer, then this product, this expression is always divisible by which value? The greatest value. So these are 5 consecutive integers, right? K minus 2, k minus 1, k plus 1, k plus 2. This will always be divisible by 5 factorial, which is 120. Getting my point? This will always be divisible by 5 factorial. समझ गए बात को? Now what is the answer of this question? From 1 to 999 every digit is used how many times? 200. No, that is wrong. 200 is not correct. Every digit is used 300 times except 0. We are not talking about 0 here, except 0. Okay, here also we are not talking about 0. 0 is used 9 times here. 10 to 90, 10, 20, 30, 40. In this case, every digit 1, 2, 3, 4, 5, 6, 7, 8, 9 is used 300 times, not 0. Then, fourth point. Fourth point is the relation between odd and even integer. What is that? Odd plus minus odd will always be even. Odd plus minus even will always be odd. Even plus minus even will always be odd. Sorry, will always be even. And if we consider the product, what we can say, odd into odd will always be odd. But if we take even into anything, does not matter, it will always be even. Even into odd is even into even is even. Okay, so कोई भी वैल्यू हो ना, इस पे भी बहुत अच्छे क्वेश्चन बनते हैं. All right, this is a very basic concept, but if this concept is not in your mind, then you might miss the question. Okay, that how to solve these type of questions. That's why I am repeating it, so that these type of questions will be, these type of concepts will be in your mind. Okay, and you can attend any question. So note it down before we move to the next slide. Noted? चलो आगे बढ़ते हैं. Let's talk about the divisibility rules. Now we are going to talk about divisibility rules. Now, in case of divisibility rules, what we can say, the divisibility rule of 2. What is the divisibility rule of 2? That last digit should be divisible by 2, or it should be 0, 2, 4, 6, 8, right? Last digit should be, so divisibility rule of 2 will be last digit should be 0 or divisible by 2, meaning 2, 4, 6, 8, है ना? What is the divisibility rule of 4? It will be last 2 digits. In case of 4, the divisibility rule is last 2 digits should be 00, okay, 0, 0 or divisible by 4. Okay. Similarly, we can say that the divisibility rule of 8 will be last 3 digits should be 000 or divisible by 8. Then only the whole number will be divisible by 8. So similarly, we can generalize this and we can say that for divisibility rule of 2 to the power n, last n digits should be 000 n times, right? 000 n times or divisible by 2 to the power n. Okay. Same rule we can apply for 5 to the power n. For 5 to the power n, we can apply the same rule that last n digits should be 000 n times or divisible by 5 to the power n. Means what is the divisibility rule of 5? Last digit should be 0 or 5. What is the divisibility rule of 25? So last two digits should be 00 or multiple of 25. It can be 25, 50, 75. So what is the divisibility rule of 125? 125 is 5 to the power 3. So last three digits should be 000 or it should be a multiple of 125. Means it should be 125 or 250 or 375 or 500, 625, 750, 875, like this. You don't have to check the whole number. Does not matter how big that number is. You don't need to check it. You can simply check the last n digits and find that if this number is divisible by particular number or not. Okay? Understood? Apart from this, what are the divisibility rule of other numbers? Okay. Example, see, you can take any number. Like if I take a number 5, 2, 7, 9, 8, 7, 4, 8. Is this number divisible by 16 or not? This number is divisible by 16 or not? So what is 16? 16 is equal to 2 to the power 4. So check the last four digit. 8, 7, 4, 8. Is this number divisible by 16? So 16 into 5 is 80. 74, 16 into 4 is 64. Then 108. Not divisible by, right? Not divisible. So this number is not divisible by 16. We had to check only last four digits. Okay? Done? Clear to everyone? Yes? All right. What's next? In divisibility rule, what next that we need to know? Divisibility rule by 3. Divisibility rule by 3. So, in case of 3, what we can say? Sum of digits. Sum of digits of the given number should be divisible by 3. Same is the divisibility rule of 9, which is sum of digits should be divisible by 9, right? Same rule, but that is not true for 27. Okay, be aware of that. Then comes the divisibility rule of 11. What is the divisibility rule of 11? It says the absolute difference the absolute difference between sum of odd placed digits and sum of even placed digits should be 0 or multiple of 11 or multiple of 11. This is the divisibility rule of 11. Okay. Now, it does not matter how long the number is, you can always check the divisibility rule of 11 very easily using this concept. Okay. For example, let's say if I am taking a number something like 7, 2, 8, 5, 6, 9, 2, 8, 1. I need to check if this number is divisible by 11 or not. I need to check if this number is divisible by 11 or not. So, what I am going to do? I am going to take the odd place digits. So, 7 plus 8 plus 6 plus 2 plus 1. So, 7 plus 8 plus 6 plus 2 plus 1. Then I am going to take the sum of the rest of the digits. Second place 2 plus 5 plus 9 plus 8. This is equal to 15 plus 9, 24. The absolute difference. Take the absolute difference. Minus. This will be 17 plus 7, which is 24. My God. This is equal to 0. Meaning this number is divisible by 11. This number is, that says that this number is divisible by 11. Getting my point? 7 plus 8 plus 6 plus 2 plus 1, then 2 plus 5 plus 9 plus 8. So the difference you can see is 0. This is how you check the divisibility rule of 11. Is that clear, everyone? बताओ समझ में आ गया सबको कैसे यूज करना है divisibility rule of 11? Okay, clear? All right then. Next, let's go to the next part. About the divisibility rule, what else can we say? About the divisibility rule, we can use some algebraic divisibility rule. Okay. Divisibility rules. What we can say, the first one is x to the power n plus y to the power n is always divisible by x plus y when n is odd. When n is odd, x to the power n plus y to the power n is always divisible by x plus y. Then comes the second, x to the power n minus y to the power n is always divisible by x minus y. Okay, this is always divisible by x minus y, where n is natural number. N is natural number. For any natural number, this is always true. Then the third one, what else we can say? X to the power 2n minus y to the power 2n is always what we can say, divisible by x plus y and x minus y both. X plus y and x minus y both. This will always be divisible by x plus y and x minus y. Okay. Then fourth point, we can say that x1 to the power n plus x2 to the power n till xm to the power n is always divisible by x1 plus x2 till xn when n is odd and x1, x2 till xn are in arithmetic progression. Okay, x1 to the power n plus x2 to the power n plus xm to the power n is always divisible by x1 plus x2 plus till xm when n is odd and x1, x2, x3 till xm are in arithmetic progression. Okay. थ्री नंबर्स का एग्जाम्पल, 3 नंबर का इसका, टेक एनी वैल्यू लाइक 15 to the power 10 minus 11 to the power 10. This will always be divisible by 26 and 4. 26 से भी divisible होगा, 4 से भी divisible होगा. 15 plus 11, 15 minus 11. Okay. Then we can say a polynomial of x, which is fx, is divisible by x minus a if fa is equal to 0. Polynomial of x, fx, polynomial of x which is fx is divisible by x minus a if fa is equal to 0. ठीक है, मीन्स x को a से रिप्लेस कर दो, अगर वो 0 आ जा रहा है तो वो पूरा का पूरा पोलिनोमियल डिविजिबल होगा x माइनस a से. Okay, done. Let me know once you are done with this, then we can go to the next part. देखो examples we can give, but that will take lots of time. We won't be able to revise it in time. Okay, x to the power n plus y to the power n is always divisible by x plus y. If you take any number 21 to the power 23 plus 31 to the power 23, this will be divisible by 52. Okay, because power is odd, just because the power is odd, this will be divisible by 52. Similarly, if I take here something like 57 to the power 44 minus 33 to the power 44, this will be divisible by 57 minus 33, which is equal to 24. Okay. Rule 5 polynomial of x. See, मान लो कोई एक्सप्रेशन है 3x² माइनस 5x प्लस, और थोड़ा सा और बढ़ा लेते हैं 4x³ प्लस 3x माइनस 5x, 3x² माइनस 5x, ऐसा रखते हैं, ठीक है। तो इससे now this is our fx, this is our fx, this is divisible by x minus 1 or not, this is divisible by x minus 1 or not, can you tell me this? fx अगर इसे डिवाइड करें x minus 1 से, will this be completely divisible? So how do we solve this? What do we do here? Check the fifth point. Let me know if this is divisible by x minus 1 or not. क्या करेंगे? We need to find f1. Just replace x by 1. f1 will be equal to, so 4 into 1 cube, which will be 4, 3 into 1 square, which will be 3, minus 5 minus 2, this will be equal to 0. So from there we can say that this is divisible by x minus 1, or you know, from there you can also find the other factors of this. Like if this is equal to 0, how do we solve this? 4x cube plus 3x square minus 5x minus 2 is equal to 0. If ever you get cubic equation, how do you find the roots? Okay, let it be they are real or they are imaginary, we don't know. Pookie, no, that was divisible by x minus 1, okay, because f1 is equal to 0, it will be divisible by x minus 1. So now we know that this expression is divisible by x minus 1, so we can factorize it in terms of x minus 1. How do we factorize it? See, we need to break it such that we can take x minus 1 common, okay. So if we have 4x cube, can you tell me what should be the next term in x square such that we can take x minus 1 common? What should be the next term? If I take next term as 4x square, then I can take 4x square common and x minus 1 can be taken as common, right? See? So we need to break it like that. Can I write this as 4x cube minus 4x square, but this is 3x square, so we will have to make it 7x square. If this is 7x square, next term should be minus 7x, then next term will be 2x, to make it minus 5x, minus 2 is equal to 0. Or we can take 4x square common, this will be x minus 1, then take 7x common, this will be x minus 1, then take 2 common, this will be x minus 1 is equal to 0. Then out of all these three terms, you can take x minus 1 common, then we will have 4x square plus 7x plus 2 is equal to 0. So from there, one of the root will be x is equal to 1, and from here, what will be another rest of the two roots? X will be equal to minus 7 plus minus square root of, using the formula b square minus 4ac, 7 square 49, then 4 into 2 into 4, 8 into 4, 32, right? 32, so this will be 17 divided by 8. So these are the three values of x. Okay, these are the three values of x that you can find out. This is how you can solve cubic equation if you ever get it. In case of cubic equation, what do we need to do? हमें यहाँ पे x की वैल्यू रख के चेक करनी होती है. क्या रख के चेक करनी होती है? You should put x is equal to 1 or -1, 2, -2, 3, -3. All of these values you should put instead of x. और जहाँ पे भी 0 आया उस हिसाब से फैक्टराइज करके you can find the roots. All right? अदरवाइज क्यूबिक इक्वेशन को सॉल्व करने का ऐसे कोई फॉर्मूला नहीं है. जैसे क्वाड्रेटिक इक्वेशन को सॉल्व कर सकते हो ना, वैसे क्यूबिक इक्वेशन को सॉल्व करने का कोई फॉर्मूला डायरेक्ट नहीं है, है ना? कभी देखा है कोई फॉर्मूला? बताओ कि क्यूबिक इक्वेशन को सॉल्व करके कोई फॉर्मूला आया हो जिससे रूट्स निकाल सको? नहीं ना. सो ये कॉन्सेप्ट बहुत इंपॉर्टेंट है. अगर कभी क्वेश्चन आता है व्हाट आर द रूट्स ऑफ दिस क्यूबिक इक्वेशन और लाइक दैट, चलो लेट्स गो टू द नेक्स्ट पार्ट. सो नाउ वी आर डन विद व्हाट, वी आर डन विद डिविजिबिलिटी रूल्स, है ना? जो भी आपके कॉन्सेप्ट में है दैट वी आर डन विद. थोड़ा सा जो बचा है वो कंपोजिट नंबर का है. सो डिविजिबिलिटी रूल्स ऑफ कंपोजिट नंबर, व्हाट डू वी नो अबाउट दैट? Divisibility rule of composite number. Divisibility rules of composite numbers. Now in this case, number should be written as, whatever number is given, number should be written as product of factors which are co-prime to each other, which are co-prime to each other. Now what does that mean? What is the divisibility rule of 12? How do you calculate if a number is divisible by 12 or not? So 12 can be written as 3 into 4. 12 can be written as 3 into 4. 3 and 4 are co-prime to each other. You cannot write it as 6 into 2. ठीक है? 6 और 2 दोनों से चेक करने से काम नहीं बनेगा, because 6 and 2 are not co-prime to each other. So you need to write 12 as 3 into 4. अगर 12 से डिविजिबिलिटी रूल चेक करनी है, divide the given number by 3. If that is divisible, divide the number by 4, then you can say that that number is divisible by 12. For example, let's take a number 721982, let's say 3 6. Now tell me, is this number divisible by 12 or not? This number is divisible by 12 or not? How do you check it? No, it's not divisible, right? Because last two digit is 36. Last two digit is 36. Divisible by 4. This is divisible by 4. But if you take the sum, 7 plus 2 plus 1 plus 9 plus 8 plus 2 plus 3 plus 6, which is equal to 9 plus 10, 19 plus 10, 29 plus 3, 32 plus 6, 38. 38 is not divisible by 3. Not divisible by 3. So what we can say, this whole number is not divisible by 12. Okay, is that clear? Sum is not divisible by 3. Yes, Pookie, that is correct. If sum is not divisible by 3, the number is not divisible by 12. Okay. Now, similarly, if you want to check more composite numbers, like let's talk about 36. If I want to check if a number is divisible by 36 or not, which two numbers should we check? Tell me, कौन से दो नंबर से डिविजिबिलिटी चेक करनी चाहिए हमें, सो दैट वी कैन से दैट नंबर इज डिविजिबल बाय 36? Four and 9, yes, we should check the divisibility rule by 4 and 9, not 18 and 2, not 6 and 6. It can only be 4 and 9, nothing else, right? So in case of 72, we should break it as 8 into 9. If you are checking the divisibility rule of 44, you should check it by 4 into 11. Okay, so I hope this is clear. How do we check the divisibility rule of any composite number? है ना? For any composite number, this is the divisibility rule. Which one is not divisible by 36? This number. So this number is not divisible by 12. 12 is a factor of 36. If number is not divisible by 12, how could it be divisible by 36, right? अगर फैक्टर से ही डिविजिबल नहीं है तो नंबर से डिविजिबल कैसे होगा, right? So now we are officially done with divisibility rules. Now let's talk about factor theory or properties of factors. Properties of factors. है ना? So what do we know about properties of factors? That if n is equal to a to the power x, b to the power y, c to the power z and so on, then number of factors of n, which we can denote as NOF of n, that will be equal to x plus 1 into y plus 1 into z plus 1 and so on, where, can you tell me what are the values of ABC? Can you tell me anything about ABC where ABC are? What about ABC? With respect to n, what can we say about ABC? Can we have two co-prime pairs of a number? Yes, we can definitely have. We can have it. Yes. Why not? Like 105 can be written as 3 into 35 or 15 into 7, है ना? Or 21 into 5. रोकी 7 से डिविजिबिलिटी रूल का कोई पर्टिकुलर मेथड नहीं है ना? जैसा 11 का है या 9 का है, सिंपल मेथड नहीं है. ऑल्दो देयर इज अ मेथड दैट आई कैन टेल यू, बट आई डोंट थिंक दैट इज यूजफुल. So in that way, there is also a rule of 13 as well. There is also a rule of 101, then 1001, a divisibility rule by 99, 999. So 27 से डिविजिबिलिटी रूल है, 37 से डिविजिबिलिटी रूल है, बट दोज आर नॉट नेसेसरी. So in that case, what we can say, ABC are prime factors. What are ABC? Prime factors of n. Okay, prime factors of n, and the power x, y, z are of course natural numbers. Okay, triplet rule. Yes, Rocky. That again, that triplet rule is very specific, right? छोटे नंबर के लिए वो अप्लीकेबल नहीं है. यू कैन यूज दैट ट्रिपलेट रूट, +3, टेक 3 डिजिट, -3 डिजिट, 3 डिजिट, वही कह रहे हो ना, टेकिंग 3 डिजिट एट अ टाइम. दैट्स द सेम रूल फॉर 13. डू यू नो दैट? सेम रूल कैन बी अप्लाइड फॉर 13. So these are the prime factors of n. Now apart from this, if I say this is point 1, second point, what we can say, that product of all the factors n is equal to n to the power number of factors of n by 2. n to the power number of factors of n by 2. Third one, what will be sum of factors? So sum of factors, sum of all the factors of n, we can say this will be equal to a to the power x plus 1 minus 1 divided by a minus 1, b to the power y plus 1 minus 1 divided by b minus 1, c to the power z plus 1 minus 1 divided by c minus 1, and so on. So number of factors, product of all the factors, sum of factors. These three things, okay? So note it down and write done if you are done with it, okay? Done? Chalo. Next we can talk about in factor, properties of factors. Fourth point is number of factors of n which are multiples of m is equal to number of factors of n upon m. Okay, I will give you an example in this concept just to understand it better. Like find number of factors of 8400 which are multiples of 14. Try this one. Find number of factors of 8400 which are multiples of 14. Try this one. What is your answer, guys? In this question, how do we solve this? What's the solution? बताओ, नहीं आ रहा? चलो, मैं हूं ना. We can find number of factors of n upon m. N is 8400, m is 14. That's it. This will be equal to number of factors of 600. Now take the prime factorization of 600. So number of factors, this will be equal to 2 to the power 3, 3 to the power 1 into 5 square, which will be equal to 3 plus 1, 1 plus 1, 2 plus 1, which will be equal to 4 into 2 into 3, and that is equal to 24. 24 such factors are there. Okay, how many factors? 24 such factors are there, which are multiple of 14. Shaurya, yes, your answer is correct. How to factorize easily? See, you will have to break the numbers. Okay, like if you are trying to factorize 8400, write down 84 into 100 first. 84 can be written as 21 into 4. 100 is nothing but 10 square. 21 is 3 into 7. 4 is 2 square. 10 is 2 into 5, so 2 square into 5 square. Then you can write it as 2 to the power 4 into 3 into 5 square into 7 to the power 1. Although in this question, you don't need to factorize 8400. You can factorize 600 after dividing it, right? But initially, you will have to factorize number like this before you have some practice and you can factorize the numbers in your mind. So practice तो करनी पड़ेगी, है ना? प्रैक्टिस करने से ही होगा ये. Now, what's next? Are we done with this? Next slide पे चलें. All right then. Next point, which is 5th point. Okay, what we can say that every perfect square will have odd number of factors. Odd number of factors. This number of factors will be always odd. If you find how many factors 4 has, 4 is 2 square, 3 factors. How many factors 36 has? 36 is 2 square into 3 square. 3 into 3, 9 factors, right? So number of factors any perfect square will have is nothing but odd, and the opposite of that, every number which is not a perfect square, will have even number of factors. ठीक है. Then comes the seventh point, which is number of factors of n which are less than square root of n is equal to number of factors of n. Number of factors of n which are greater than square root of n. If you talk about square root of n, जितने फैक्टर्स उससे पहले होंगे उतने ही फैक्टर्स उसके बाद होंगे. ठीक है. नंबर ऑफ फैक्टर्स ऑफ n will be same before square root of n as after square root of n. Okay. Sir, how can I increase my score in QA section? प्रैक्टिस करो, सेक्शनल टेस्ट दो, रिव्यू करो उसे प्रॉपरली, है ना. जो भी टॉपिक वीक है उसे फिर से रिवाइज करो, फिर से उसके क्वेश्चंस प्रैक्टिस करो. ओके. बी इन कॉन्टेक्ट विद योर फैकल्टी, विद योर मेंटोर एंड डिस्कस योर स्कोर्स विद हिम और हर कि क्या मार्क्स आ रहे हैं, कितने अटेम्प्ट्स हैं, एंड फॉलो द एडवाइस. वट एवर दे से, फॉलो देयर एडवाइस. ओके. Okay, then comes the eighth point, that number of ways n can be written as product of two factors, will be equal to number of factors of n divided by 2. Okay. Number of ways n can be written as product of two factors is number of factors of n by 2. क्वेश्चंस मटेरियल चाहिए तो बुक खरीदो भाई. यहाँ पे क्या कैसे मिलेगा क्वेश्चंस मटेरियल? अटेंड द लाइव सेशंस, उसमें भी बहुत सारे क्वेश्चंस डिस्कस होते हैं, है ना. बट यू नीड टू सॉल्व इट फ्रॉम बुक. देन कम्स द नाइन्थ पॉइंट विच सेज नंबर ऑफ वेज n can be written as product of two factors which are co-prime to each other, is equal to 2 to the power k minus 1, where k is number of prime factors of n. Okay, where k is number of prime factors of n. All right. Now in this case I will give you one example just to understand. Okay. So in how many ways in how many ways 8400 can be written as two factors which are co-primes or which are co-prime to each other. Now can you tell me the answer of this question? In how many ways 8400 can be written as product of two factors which are co-prime to each other? Surya, you can purchase iQuanta book. Okay, iQuanta books. Go to the website and check IPMAT page. Okay, you will find the link for books. Other than that, I cannot say any other book name on public platform. I hope you can understand, right? Everyone, try this question. Tell me your answer. What will be the answer of this question? What will be the answer of this question? चलो देखते हैं. First we need to find how many prime factors 8400 has. Can we say prime factors of 8400 are 2, 3, 5 and 7, means 4 prime factors. Okay, so what will be our answer? What will be number of ways of writing 8400 as a product of two co-prime factors? This will be equal to 2 to the power 4 minus 1, which is equal to 2 to the power 3, and that will be equal to 8. All right, 8 ways. Yes, yes, Shaurya and Pookie, both of you got this correct, right? 8 ways. All right. So with that, we are done with 2 subtopic of numbers. One of them is divisibility rules, and other is properties of factors. The bonus was classification of numbers, natural numbers properties, right? So I'm going to continue tomorrow, and we are going to discuss formulae based on some more topics on numbers. All right. Nama, in this case, check prime factors of 8400. We did the prime factorization of 8400 here. Where? This one. So 2, 3, 5, 7. Number of prime factors of 8400 is 4. Number of ways will be 2 to the power k minus 1, all right, which is 4. Okay. All right. So yeah, yes, we will learn Euler's theorem as well in the upcoming classes. Okay. So thank you everyone. Thank you for joining us. Let me know your feedbacks in the comment section. Okay. Are you looking forward to the next session tomorrow 4:30 p.m. or not? Okay. And if you like it, share it with your friends as well. Thank you.